Hello everyone, and thank you for joining us today. We are excited to present our project titled Sales Prediction System, a cloud-based application for revenue forecasting using machine learning. And we are group 6 and my index number is ICT 343, and this system represents the outcome of our efforts to solve a common challenge faced by many businesses, accurately predicting future sales. In today's fast-paced market, making informed businesses decisions is crucial, and our solution leverages machine learning and modern web technologies to provide just that. And let's take a closer look at what our system is designed to do. Um, our system has been designed with both functionality and user friendliness in mind, and its core it uses a machine learning model to predict future sales revenue based on the data provided by the user, and users can input product and sales data through a simple interface, and the system processes this data and returns meaningful predictions. And administrators have additional privileges. They can manage user accounts and oversee forecasting operations. And to ensure easy deployment and scalability, we have packaged the entire application using Docker and hosted it on Microsoft Azure. And the results and predictions are displayed through an interactive dashboard with charts and graphs, making it easier for users to understand trends and insight at a glance. Mm, we will move to the next slide. Uh, Under the key features, our system includes several key features to enhance both its functionality and user experience. First one is user authentication, um, and this ensures that each user accesses the right content securely. Role-based access lets administrators and general users have separate levels of control. And second one is revenue forecasting, and this feature is powered by a robust gradient boosting machine learning model known for its high accuracy and predictive analytics. And we have created an interactive dashboard using Chart.js, and it gives a clear visual representation of data, helping users make sense of predictions quickly. And finally, the entire system is uh, Dockerized, meaning it's easily portable, scalable, and consistent across different deployment environments. And altogether, these features make our system a powerful tool for data uh, driven decision making in sales. And now I will move to the our coding part of our system. So these are the templates uh, of our user interface. Um, First one is admin.html. Uh, this admin.html file uses several technologies. HTML5 for the structure of the admin dashboard, and CSS and Bootstrap 5 for styling and layout, and Font Awesome for using icons, and JavaScript with Bootstrap.js bundle um, for interactive components like models and collapsibles, and Chart.js is included for visualizing charts. And Jinja 2 templating is used to dynamically display data from the Flask backend. So let's move to the dashboard.html file. And this dashboard.html file is part of the sales predictor web app, and it's built using HTML5 for the page structure and layout, and CSS and Bootstrap for styling, responsiveness, and consistent UI components, and Font Awesome to add icons throughout the dashboard, and JavaScript. We used here in this code JavaScript for interactively, like toggling tables and deleting forecasts, and Chart.js to render interactive charts like revenue trends and category distributions. And we will move to the settings.html. This is also created using HTML5, CSS plus Bootstrap, and JavaScript used for interactively, like copying API keys, collapsing sections, and sending AJAX requests. So the page includes multiple collapsible cards for editing profile info, um, updating account settings, managing notifications, accessing APIs, and exploring clear data, all wrapped in a user-friendly, responsive design. And so that's all about my part, and I will hand over the presentation to continue Hiruni. Thank you.
Thank you, Himashi. I'm Hirune. So in here you can see these are the tools and text summary that we use for our system. For front end, we use Tailwind, CSS and Bootstrap 5 for responsive and clean layouts. For icons and visuals, we use Font Awesome, which gives users visual courses like login or password icons. And also we use Ginger to templating. So that allowed me to show server-side messages dynamically. For example, we can display an error like invalid email or password. For backend, we use Flask as our web framework. For database and authentication, we use Firebase Real-Time Database and Firebase Auth, and also machine learning model. For that, the core of our prediction system is built with scikit-learn using gradient boosting algorithm. For next one is system components. In here, you can see these are the system components. First one is user authentication and prediction engine, analytics, dashboard, and finally admin panel. For authentication is my main component. I built the user login and sign up pages with user validation and error display. For prediction engine, our machine learning model process previous data to provide accurate sales forecast. For analytic dashboard, offer visualizations that help users to understand and analyze sales trends. And finally, admin panel. Admins can manage users, input data, and control system configurations. Then next one is future plans. So in here you can see these are the future plans that we hope to improve for our system. For advanced analytics, we aim to include coherent analytics and adjustment for seasonality to enhance forecasting. And also we plan to enhance models also. So we plan to experiment with proper models and integrate automatical model training for our ongoing learning. And finally, collaboration features. In future, we would have to definitely we have to collaborate with other people. For example, teams sharing prediction results and one account, which will require excluding the current authentication system. And instead of these future plans, we plan to add password recovery features using Firebase built-in tools. And another idea is two-factor authentication. These are the future plans that we plan to uh, include our system. So next move to the coding part. So in here, you can see this is the coding part of our system. So I work on the authentication part. This one include login.html, signup.html, and index.html pages. So these pages allow users to securely login and register to the our system. So first one is sign up page. You can see this is the signup.html file. In here, the sign up page allow users to create an account using their email and password. So I style it using Tailwind CSS and add font awesome icons for better from UX. You can see. And also the form is responsive and include animation effects also. You can see this is the output of my sign up page. So in here you can see this is the output of my sign up page. So next one is I design login page also. So this is the coding part of login page. The login page let existing users to sign in securely. It reuse the same design pattern for consistently email password fields. And also I implement basic validation and hover effects for polish loop. So you can see this is the coding part. Then move to the login page output. So this is the user interface. And next one is index page. So index page act as the post login landing area or a potential start for prediction. So it includes a simple form, navbar branding, and follows the same styling principle as auth pages. So it's respective light dark mode friendly and offered consistent visual experiences also. So this page can later serve as a home for prediction features or user dashboard. So I use navigating bar with project branding and a so this is the output of my index.html page. And then you can see this is the output. And then now we will move to the live demonstration. So it's time to live demonstration. So we will walk you through the system starting from user login, entering data, gathering predictions, and viewing the dashboard. So this will show how our system can be used in real world scenario to support business decisions. So that's all about my part. So I will I will stop in here. So demonstration part continue by Nipul. Thank you.
Thank you, Hiruni. I am Nipul Sandeepa, and I am excited to demonstrate our sales forecasting project. So it is a web application designed to predict sales revenue using machine learning. And here's a quick overview of the tech stack. So the backend is built with Flask, which is a lightweight Python framework, and we use Firebase, authentication, and real-time data storage. For machine learning, we train a gradient boosting model with scikit-learn, and this app is containerized with Docker and deployed on Azure App Service for scalability. Now let's dive deeper into how it all works. So now I will just describe the technical architecture. So this system follows a three-tier architecture. Now I will just first explain the front end. So here we have a folder called template. So within that we have several files like admin, dashboard, edit user, index, login, settings, sign up. So these are the files related to our front end. So this is the admin file, which has the functionalities related to our admin route. And here we have the dashboard.html file, which is the file which contains charts and tables of predictions. So and also this is the signup.html file, and this is the login.html file. So now I will get to the back end. So this app.py, this file is the main entry of our project. So this is so basically what this does is that it serves prediction and manages user interaction. So as key features, I can say user authentication. So we can log in, sign up using Firebase Auth, and also here we have several routes. So this is one of the most important routes, predict route. So this takes form input, validates data, and returns revenue prediction. And next we have our dashboard route. So this route displays prediction, charts, and KPIs. KPIs like total revenue, highest prediction, average prediction. And we have several routes. So here we have a route that allows us to delete prediction details. And also we have a route that allows us to export our data. So we can export our data as a CSV file, and this is the route that is related to our settings.html file. And also we have a route called generate_API.key. So this is basically an API endpoint. So it provides external access to prediction data. So like that, we have a several number of routes. Now I will explain this train model.py. So this is the file that trains a machine learning algorithm to predict sales revenue. So it loads data from sales underscore data.csv file. So here we have that file, our data set. And secondly, it handles missing values and converts data types. And as the third step, it removes outliers and performs log transformations on the target variable, which is revenue. And it uses gradient boosting regressor with grid search CV for hyperparameter tuning. And this is the piece of code that saves the trained model as model.pkl and feature column. This is the and this is the piece of code that evaluates the model performance using MSE and R squared metrics. And this is the piece of code that shows feature importance and a sample prediction. So that's it about this train model.py. So now I will describe our requirements.txt file. So these are the requirements which is required for this project to work without any hassle or any trouble. So here we have several packages like Flask, Firebase Admin, Pandas, NumPy. So these are very important for this project to run if smoothly and without errors. So and this is our Docker file. So this is the file that we use to create a container. So actually we faced a lot of problems with this requirements.txt file because actually when we tried to create the container, we got some errors like NumPy version mismatch. So we actually did this project using the latest Python version. So because of that, some of the packages that we have used locally don't really match with the requirements of the Docker environment. So several times we couldn't create the Docker file, we got errors. So, but we tried downgrading NumPy package and upgrading it and using different versions of each package. And finally, we actually were able to containerize this whole project. So, and now I will show you our Docker image using this Docker image ls command. So as you can see, this nipple 247/predictor. This is the Docker image that we created, and we have pushed this Docker image to Docker Hub, and from that, after that, we created an app service on Azure Cloud, and we pulled that Docker image from that Docker Hub into our Azure web app. And now I will show you our service account key.json file. So this file contains Firebase admin SDK credentials, allowing our app to securely access Firebase services. And so in production, we would use environment variables or Azure Key Vault. So now, as I have mentioned earlier, we use Docker to containerize this application. So, and we deploy the container to Azure App Service. And now I will show you how this project works. So as you can see, I have logged into my Azure account. This is our web app, which is deployed on Azure App Service. So now I will click on this browse. So as you can see, we were redirected to our login page. Now I will first log in as a user, then submit a prediction so that you can see how predictions are executed. So now I have just logged in as a user into our project. So now, as you can see, no predictions have been done. These are our URLs. So this is the predict URL. This is the settings URL. This is the logout URL. Now I will do a prediction. So when that prediction takes place, our dashboard is automatically updated. Here I will just give a product ID like this. Then I will give a product name like t-shirt. Then I will give the category, which is clothing, and price is around, let's say, $3.5. So here we have used dollar for prediction. Now here we need to enter the number of units that were sold. Let's say it's around, let's say it's 3. Now here we have the marketing factors. So if this is a promotion, we can choose an option whether this is a promotion or not. So I'm gonna go with no. And here we can say this is a holiday flag or not. So I'm gonna go with no with this one also. And as the competitor price, I'm going to enter $3.8. So no special events. I'm gonna set it as none. And as time factors, I'm gonna choose Friday. And the month is, I'm gonna I use 6 as the month. Now here we have the button which is predict revenue. So I'm gonna go ahead and click on it. So as you can see, our dashboard was automatically updated. Here we can see the total predictions as 1. And here we have the latest predicted revenue, highest predicted revenue, average predicted revenue, and this is our total prediction revenue. And these graphs were automatically created after our prediction. So here we have the table which displays our prediction details. And now I will again submit a prediction. Here I'm going to use the ID and product name, I'm gonna use mobile phone, and as the category, I'm gonna choose electronics. The price is $100 and units one. Marketing factors no, holiday flag no, special links holiday sale, competitive price like as $102. I'm gonna choose Friday 6. Now I'm gonna submit this prediction. So as you can see, the number of predictions increased to 2, and our all the pie charts, uh, graphs got updated after our prediction. Here we can delete our predictions. So now I will delete this one. So as you can see, after that our dashboard got updated, and this is this data export option allows us to export this prediction details. Now I will click on it. So as you can see, it was updated. It generated a CSV file containing our prediction details. Now I will show you that CSV file. So as you can see, this is our prediction details. So in this settings page, we have the ability to change our display name, company name, and we can update our password and emails, and we can set our notification and email notifications and SMS notification preferences. And under data management, we can export our user data. So when we export our user data, we will download a JSON file, and we also have the ability to clear our forecast data. And here we can generate an API key, so we can use this API key to access our REST API endpoints. So this is very useful when we don't really want to use the web interface. So we use bearer token for this. So we can use a tool like Postman to test this. And now I'm going to log out of this account and log in as an admin. So as you can see, when we log in as an admin, this admin URL is shown. This URL is only visible when we log in as an admin. So I'm going to go ahead and click on it. So as you can see, we can see all our users who logged into this application. Here we can also see the number of users, number of active users, and the number of total predictions. And also we have an option to clear all the forecasts of every user. Here we have an option to add user. Now I will just add an user. I'm going to give the email as this one and the password as this one and the display name as this one. And I'm going to give the display name as this. and we can actually decide whether this user is going to be an admin or just a user. Now I'm going to make this user an admin. So, and I'm going to click on this create user button. So as you can see, the new user has been added to our database. Here we can view it here, and the role is admin, and all our prediction details and user details are saved to our Firebase real-time database. And now I will go ahead and show you our database. So this is our real-time database. So as you can see, our forecast details are included here. So this is the prediction that we submitted a few minutes ago. So here we can see the category, holiday flag, price, product name, promotion, units sold, everything we can see here. Also here we have a collection called users. So this collection contains the details of users that log in or signed up in for this application. So these are the functionalities of our project. So we can say that we have done something. So that's it about our project. So we can say that we have created um, a web application which can be used to predict sales. So, and we think we have done a great job. So, um, thank you for your cooperation. So, thank you very much.